Right. So before we start solving problems in two-dimensional mechanics with Newton's laws, it's important to get a working knowledge of vectors. You could use any standard textbook in physics, for example, Resnick and Halliday. The first question that comes to mind is why vectors? So I'll simply write down an answer saying that the laws of physics can be stated very compactly and elegantly um, with vectors, and also vectors facilitate calculations which will be very efficient. But I would also at this stage like to direct you to Feynman's chapter on vectors. I think it's chapter 8 and volume 1. For now, I'll just give you examples of the statement, but I'll just leave you with an enigmatic statement saying that behind all this is a frame of reference, so on which we've been stressing right from day one. So the first and foremost formula of physics for me is Newton's second law for a particle, which says F is equal to mass into acceleration of the particle. And here you can see that both F and A are vectors. There are two more interesting formulae that we will use heavily in this part of the physics that we learn, and I'll just write it here. The force external on a system is equal to the rate of change of linear momentum on the system, and here both P and F are vectors. There's a third important formula that I would like to write here for the record. Torque external on the system is equal to the rate of change of angular momentum, which we denote by L, and both tau and L are vectors. You also see the appearance of rates of change, which is essentially calculus. So calculus plus vectors is going to be a very powerful team for us. We'll be picking up some calculus pretty quickly. Now, using these two formulae combined with the conservation of energy is all we need to solve all the problems of mechanics. This is indeed a statement of purpose, and we would like to justify this as we learn mechanics over the next few classes. So for now, I will go to the next video and try to focus on some basic conventions of vectors.